Okay, so welcome back my dear friends. Today we are going to talk about resistance. Okay, so the topic of physics we are going to touch today. Okay, today's date is 19th September 2019 and today is Thursday. Right? So we are going to talk about a topic of physics today, and that is resistance. Resistance. Okay. So before that, actually I did not talk about current. I did not talk about charge. Okay, means the electricity chapter. So this resistance topic is coming under the electricity chapter. So just for information, I will be telling you that what actually is the charge. Okay. Then I will be telling you what exactly is the current, that is I, and I will also be telling you that what actually is the potential difference. Potential difference, which is denoted by P. Okay, so let us start with charge. See, charge is a physical quantity. It is a physical quantity, and especially it is the electrons. Especially the charge is electrons. So that's why we are writing Q is equal to Ne. Means E is the electronic charge, and we are already knowing the electronic charge E value is 1.6 into 10 power of minus 19 coulomb. 1.6 into 10 power of minus 19 coulomb is the charge of E. Means electron. Yes, of course it is correct that the same electron which are revolving around the nucleus in an atom. Okay, so this Q is the quantity of charge, amount of charge. So number of electrons will be constituting the charge completely on a body. So charge is a physical quantity, okay, and which is having the electronic charge, the charge of an electron. Okay, so the value of the charge is 1.6 into 10 power of minus 19 coulomb. Now, what is current further? So when these electrons move in a conductor from one place to another, it constitutes a current. Okay, so the movement of charge per unit time. What is the current? The movement of charge per unit time is called current. It means the electrons, when it moves from one position to another in a conductor or in a circuit per unit time, or you can say rate of change of or rate of movement of the electrons in a conductor is called current. Is called current. Okay. Now this current direction is just opposite to the direction of electrons. Opposite to the direction of electrons. If suppose we do have a conductor A, means a conductor in which point A is on one end and B is another end, and if we say that the electron is moving from point A to B in this particular conductor AB, then actually the current will be in reverse direction of electron in a circuit. So always the direction of current will be opposite to the direction of electron. And in a circuit, if we are saying that the direction of current will be from positive terminal of the battery to the negative terminal of the battery, whereas electron movement will be from negative terminal of the battery to the positive terminal. Okay, right. So that we have discussed about current. Now let us discuss about potential difference. Potential, we all would have heard about potential energy. Okay, so when we are talking about potential, automatically that potential energy comes into our mind. So potential energy and kinetic energy, both we have already studied. Okay, so Now this potential energy is what? You can say the energy possessed by a body. It's correct definition I am telling you about potential energy. The energy possessed by a body or an object by virtue of its position. Means due to its position, the energy possessed by a body. If I am lifting this particular marker up, it means I am providing some energy to it. Okay, so what it is there at this particular position, this marker is having some position, of course, it is having some position and some energy also, potential energy. But when it is lifted up from this H1, which is from the ground level, it is 5 meters we can say, okay, or 1 meter we can say, and if I have lifted it to 10 meters, so its energy had changed and that its energy has increased. So when it will be dropped from here, it will be dropping with more velocity, or you can say more impact. So it means the energy possessed by a body by virtue of its position is called potential energy. Okay, kinetic energy we are not going to discuss here now, but kinetic energy, as for your information, I am telling you that the kinetic energy is the energy possessed by a body by virtue of its motion. So compulsorily in kinetic energy, we need motion, we need velocity. So that's why kinetic energy is equal to half mv square. Kinetic energy is equal to half mv square, and you can say this kinetic energy is directly proportional to the square of the velocity. The more velocity, the more kinetic energy. Similarly, potential energy, if we are talking about, then it is mgh. Okay, mgh. So mg is the weight of the body, and h is the height at which it is placed from the ground level. Okay, from ground level. So this h, when this h will be increasing more and more, this potential energy also will increase. Similar to that, this potential difference also. So what it is the amount of work done. It is also one type of energy. Okay, so but what it is, this potential difference is the amount of work done. Work done is also energy only. Okay, so the amount of work done for what? In bringing a charge from one place to another. From one place to another. So this movement of charge, if it is taking place from point A to point B, so how this movement is taking place? Some work is done. And that work, when I am saying that this electron is moving from A to B, so automatically it is not moving. Something we need to create, some work we need to do it, then only it will move from one place to another. So that amount of work done per unit charge is called potential difference. Then V is equal to W, that is work done, divided by Q. Work done per unit charge is called the potential difference. So potential difference is the potential, or we can say potential difference. In this case, if I will say, then VA minus VB. VA minus VB, we can write. We can write VB minus VA also, no problem. Okay, whichever it at higher potential, so VB minus VA also we can write. So this particular difference which we are getting, it is called potential difference. Okay, its unit is also volt. Similarly, current unit is in ampere and charge unit is coulomb. Charge unit is coulomb. All in the name of scientist only it is there. Okay, so this is for your information. Today's my topic is resistance. So before resistance, when I am discussing, it's my duty to tell you the basics of the terms which we are utilizing there. We will be utilizing current, we will be utilizing potential difference, and before discussing resistance, I should tell you about Ohm's law also. So Ohm's law. This one you have understood. Potential difference is the amount of work done in bringing a unit charge or in bringing a charge from one position to another. Okay? So W by Q will be giving you the potential difference, right? Now Ohm's law. Ohm's law is what? What it is saying that at constant temperature, temperature. At constant temperature, temperature is very important, gentlemen, here. Okay, so Ohm's law is saying that at constant temperature, the current flowing in a conductor is directly proportional to the potential difference. The current is directly proportional to the potential difference, and this is the statement of Ohm's law. Okay, now, so this can also be written as V is proportional to I, and further V is equal to IR we will be writing, where R is the proportionality constant. Okay, R is the proportionality constant, and which is called the resistance of the conductor. It means this resistance. Okay, where from it has come? So that proportionality constant, R is the proportionality constant, which is called resistance of the conductor. Then what actually is the resistance? Resistance is the property of a conductor. It is the property of a conductor. It is the nature of the conductor. Resistance, due to which it opposes the flow of current. For a conductor, if we are saying, so what is a conductor? A conductor which allows electricity to flow easily. An insulator which doesn't allow electricity to flow easily, or which doesn't allow current to flow easily, is called an insulator. Similarly, here that resistance is the opposition which opposes. Initially it doesn't allow, it is not allowing the electrons to flow, the current to flow. Okay, so it offers opposition. That opposition is being offered by due to this potential difference. You can say overcome by this potential difference, and then current is flowing, and in this process some generation of heat is also taking place in the conductor, and when current starts flowing, okay, then we get our resistor, bulb or fan and other things, right? But each and every material first opposes. That opposition nature of the material is called resistance. It is called resistance. Okay, so that is the only resistance V is equal to IR. Right. Now this particular resistance, now some factors we will be talking about. So it depends on first nature of material. If I am telling that nature of material, then you will be saying that what does it mean? It means what? That if it is a conductor, less resistance will be there. If it is an insulator, very high resistance will be there. Then it will not allow only the current to flow. Yes or no? So nature of material. Then second, it depends on temperature also. Temperature of the material. Okay. Then third, resistance depends on length of the conductor, gentlemen. Length of the conductor means R is directly proportional to L, length of the conductor. Similarly, it depends on area of cross section of the conductor. That is, R is inversely proportional to area. Okay, so length of the conductor directly proportional and inversely proportional to the area of the cross section of the conductor. When we are combining these two, what we are getting? We are getting R is directly proportional, or you can say proportional to L by A. Similarly, we will be getting some type of proportionality constant, gentlemen, here, and this R will become rho L by A, where rho is called what? Resistivity. Resistivity of the conductor. So resistivity is the property of the material by which it resists, it opposes the flow of electrons, the flow of current. Okay, so that is called resistivity. And I did not tell you about the unit of resistance. So the unit of resistance, gentlemen, unit of R is ohm. Unit of resistance is ohm. From that Ohm's law, this Ohm was the scientist who has discovered and who has made this law. So the unit of resistance is ohm. Now here, from here we have got resistivity, and resistivity is equal to RA by L. Okay, so this, what is the unit of resistivity now? So unit of resistivity is ohm meter. Ohm. Reciprocal of resistivity is called conductivity, which is denoted by sigma, and this one will become what? L by R. And its unit will be what? Unit of sigma is ohm inverse, meter inverse. Okay, so these things we have discussed. Resistance, yes, already we have discussed. So these things we have already discussed. Now, to give you a preparation, to give you an idea of this electricity chapter, okay, in which we discussed about Q, that is charge, we discussed about current, we discussed about potential difference, we discussed about Ohm's law, then where from that resistance concept has come, that we have already discussed. Then further we have discussed that on which are the factors this resistance is depending, that we have already discussed that R is proportional to L by A, and this formula, this expression we have derived. We discussed about resistivity, we discussed about, okay, on the basis of resistivity, high resistivity or low resistivity values. So it depends on material. We can categorize the material as conductor, insulator, conductor or insulator. If it is very high resistivity, it will be insulator. If it is very, you can say medium resistivity or very low resistivity, it is conductor. So like this it is there. So then we discussed about conductivity also. Conductivity is the reciprocal of resistivity, and the units also we have discussed, which has to be remembered ZVT. Okay. So in next video we will go for the same electricity chapter, but we will be discussing about what? We will be discussing about that resistance when they are connected in series, then how to find the equivalent resistance, how to find equivalent resistance in series and in parallel. Okay, and we will be solving one or two questions, right? So till today you have the basic knowledge of this one, and in next class we will be going for resistance which will be connected in series and in parallel, and the derivation of that particular expression. Okay, so by that time, thank you very much. Okay.